How do you define data mining? What does that involve?
Well, a specific definition of data mining is the kind of thing that's going to get you into a lot of arguments. In practice, data mining is a business-led profession, and it's about extracting statistically valid information and new insights from data. And one of the things that makes it different from statistics or pure statistics is that it doesn't assume underlying models. So in statistics, you tend to assume that there is a particular shape to the data. In data mining, you use machine learning techniques that don't have that as a default. They actually learn from experience and learn from what's in the data.
So is there a formal process? Sounds like there might not be a formal process.
Well, there have been a number of attempts to build formal processes. SAS famously have their SEMA process. But the one that I like best is CRISP-DM. And CRISP-DM was put together with some European funding back in the late 90s. And the idea was to produce a methodology that was independent of any tool sets. One of the disadvantages of SEMA, for example, is that it focuses almost exclusively on the SAS toolset. Now, that's great if you use SAS, but if you're using R or using SPSS or KXCN or one of the many other tools, it doesn't necessarily fit so well. With CRISP-DM, 4 companies were brought together. NCR, which used to own Teradata, Daimler, who produced vehicles, I believe, Aura, a Dutch insurance company, and SPSS, now part of IBM. And they worked together to produce a methodology that was really focused on the business approach, but also took into account the iterative nature of data mining. It would be lovely to think that you had a series of steps you could go through. You know, we do this, then we do this, then we do this, and we get a result at the end. In practice, we see that the process is very, very iterative. You start with an idea, you explore the data, you find that the data is a lot noisier than you expected, and that's something I think data scientists would tend to agree with as well. Sometimes you have to go back to the beginning and say, was this the right question? And then you iterate through the steps, and hopefully at the end of it you get to a valuable answer for the business.
So the process itself is more about iteration as opposed to step.
Absolutely. And core to that is the business. And I think that's one of the focuses of data mining compared with statistics, is that we're only doing this to provide value to the business. Now, whether that business is a not-for-profit, whether it's about churn modelling or whatever, it doesn't really matter. But the focus on getting good, usable business answers is key.
Is data mining an entry point for people who want to get into data science?
You could almost put it the other way around. Is data science a good way in for data miners? I don't think there's any one given answer, but I do think that data mining is a key aspect to data science. If people aren't able to understand the difference between something that looks interesting and something that provides value and that is statistically valid, then you've got problems. And we see this a lot. We see people who have great technical coding skills, who can look in the data and see things that are shiny and interesting, but don't actually ask the next question, which is, so what? It's shiny, it's interesting, but so what difference does that make? And that's one of the key lessons from data mining, really. It's the so what. How do I evaluate this? How do I make sure it makes sense? How do I actually put that into a context that is relevant for the business?
Last question for you. How do you see the tools and techniques of data mining evolving over the next 2 years or so?
Well, it's strange because if you look at the evolution of data mining tool sets, they start arising in the late 60s and early 70s. In the 80s and 90s, a lot of effort was made into making them usable for a much wider range of people. You have companies like KXCN starting. KXCN famously said, you only need 4 clicks to build a model, and later they decided that was too many and you actually only need to have 1 click to build a model. Then we have R coming along, and R has made a huge impact because it gets people away from these closed ecosystems of the big providers. But the downside is that it's like stepping back 10 years or 15 years. The interfaces to R are still very much a technical interface. They require people to focus on how do I actually make this piece of algorithm work. And the problem with that is that it drives you away from thinking about the business. And so what I think is going to happen over the next 10 years, open source will continue to grow, there is no doubt about that. But I think there's a real place for someone coming along and actually building the interfaces that make these more straightforward to use so that people can stop thinking about the algorithms and start thinking about the business value.
Great. Thank you for being with us.
It's a pleasure.